Okay, so I have length times width times height, and I drew right here my length, which it says 12 inches wide. Oh, that's going to be my width because it's 12 inches wide. And then it says the supply box must be no taller than 2 inches. So this is 2 inches for my height. Okay, so 12 times 2 is equal to 24. And now I need to figure out what could my length be, because they haven't given me a length yet. So 12 times 2 is 24, and 24 times 3 is going to give me 72. 4 times 3 is 12, 3 times 2 is 6, plus 1 is 72. So 3 is the logical answer for that. Problem 4. After all of this organizing, Ren decides she needs more storage for her soccer equipment. Her current storage box measures 1 foot long by 2 feet wide by 2 feet high. She realizes she needs to replace it with a box with 12 cubic feet of storage, so she doubles the width. Will she achieve her goal if she does this? Why or why not? So, same question as earlier. I need to figure out if she doubles the answer, is she going to get her goal? Okay, so I have 1 times 2 times 2. Okay, so let's try to double. She realizes, After all this organizing, Ren decides she also needs more storage for her soccer equipment. Her current storage box measures 1 foot long by 2 feet wide by 2 feet high. She realizes she needs to replace it with a box with 12 cubic feet of storage, so she doubles the width. Oh, okay. So right here we know the width is 2, right? This is my width, and I'm going to double it to 4. So now I have 1 times 4 times 2, and I know that 1 times 4 is 4, and 4 times 2 is equal to 8 feet cubed. And that is not going to help her reach her goal of 12 cubic feet. So I'm going to write Ren does not reach her goal. Okay, so now I'm going to go to problem B. If she wants to keep the height the same, what could the other dimensions be for a 12 cubic foot storage box? So our goal is still going to be 12 feet, right? So I know that I need to multiply length times width times height to figure out what happens if she changes it in order to get 12 cubic feet. Okay, so I'm going to multiply my length right here, maybe if I double it, by 2. And then I'm going to change my width by 3. And I'm going to change my feet by 2. Okay, 2 times 3 is 6, and 6 times 2 is equal to 12. So that would work. If you have different dimensions, it would also work. As long as you get 12 feet, then you are correct. Okay, so this is my final answer. Now, problem C. If she uses the dimensions in part B, what is the area of the new storage box floor? So the area. To find area is equal base times height. So I'm going to multiply the base, which is the width, 3, and the height, which is 2. So 3 times 2 is going to give me 6 feet squared. Whenever you answer for area, if you're creating an answer for area, notice that it's only 2 measurements, so it's always going to be square. When you're answering for volume, notice that you are calculating 3 measurements, so it's always going to be cubed. Now, problem D. How has the area of the bottom in her new storage box changed? Explain how you know. So, at first, in part A, the area was 2 feet square. In part C, the area of the box is 6 feet square.